David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. I got one for you. Why did the obtuse angle go to the beach? Because it was over 90 degrees. Woohoo! All right, today's topic, points on lines. And as you recall from the last video about line equations, a line is just composed of a ton of points that all satisfy the equation for that line. That the xy coordinates, when plugged into the equation, all work. So we're going to get all around that in this lesson. So here's kind of a definition. A given point lies on a line if its coordinates satisfy the equation of the line. Okay, and we're going to do that. You're going to for the homework, you're going to test this kind of a thing. So the point 2, 3, coordinate point 2, 3, x and y, lies on the line. Now here's a general form equation of a line, 3x plus 4y equals 18, because, now if you think you know what to do, pause the video right now and try it. I'm going to walk you through it. So what you do is you take the xy in the point and you plug them in where x, y are, and you work the equation, and the equation should work. So whatever we do to this side, it should end up being 18 because we know it equals 18. So let's try that. So the xy, that's this, x and y, we're going to do 3 times 2 plus 4 times 3 equals 18. Now I always write a plug-in step like this. Now, of course, you could do this in your mind and just write down the next step because it's pretty simple, but I urge you to write a good plug-in step. It's a really good habit to get into. Plus, when I grade your test or your quiz, this step, clearly explained, could be as much as half of the points in a problem. If you skip this step, it's harder for me to tell what you're doing, harder for me to give you partial credit. Okay, let's keep working this. So 3 times 2 is 6. Plus 4 times 3 is 12. Bring down my equals 18. And of course, 6 and 12 are 18. So this point lies on this line. So a quick summary. What we did is we have our line equation. To test the point, we put the x value in where the x is, the y value in where their y is. So that's what we did here. Here's the x, and here's the y. And then we just work our math, we calculate, and we try to make sure that we end up with an equation that works. Okay, here's one for you to try. Does the point 4, 1 lie on the line? And this is just that line we looked at just a minute ago on the last board. So go ahead and pause the video and try that technique and see if you can answer this question. Okay, let's see what you got. Plug in step first. My x value, here's the x and the y. My x value is 4, so 3 times 4 plus 4, what's my y value? That's a 1. 1 should equal 18, okay? 3 times 4 is 12, plus 4 times 1 is 4, should be 18. But unfortunately, 12 plus 4 is only 16. So this is a big no. So this point does not lie on this line. It's a valid point, you can graph it all day long, but it won't show up on that line. Okay, 2 more to do. And I want you to pause the video and see if you can work this one first, and then I'll go ahead and explain. Okay, so the point 3, -2, does it lie on this equation, this line? 6x plus 3y equals 12. Plug-in step comes first. 6, here's my x and here's my y. 6 times 3 plus 3, my y is -2 times -2 equals 12. Let's work it. 6 times 3 is 18. 3 times -2 is -6, so 18 minus 6 equals 12. 18 minus 6 is 12. So that's a yes. This point lies on that line, and we tested it. Okay, now this one is a little different. I've put the equation in gradient intercept form, but it's still the same test. So you can plug in the x and the y, x, y into this equation in the correct spot, and it should work. So go ahead and pause the video, see what you get. Okay, let's do that. So my y value is 5, that goes out here, equals minus 1/2 times 4 plus 7. Okay, so I just plugged in my y for the y and x for the x. Now let's work it. Minus 5, and negative 1/2 times 4. So first off, 1/2 times 4 is just 2. Negative 1/2 times 4 would be negative 2. And I think you see where this is going. So that one also lies on that line. Okay, so some of the problems start to get a little bit more tricky, but it's the same idea, it's the same concept. You just have to remember that if a point lies on a line, then the xy coordinates of that point will satisfy the line equation. Okay, so here's an interesting one. Find k if the point 3, 5 lies on this line. And notice how usually when we have general form, we have a number for our constant, but they put k there. They're asking us to find k. And then they tell us that 3, 5 is on this line. So what we have to do here is just plug in x and y where they show up, work the math, and that will tell us what k is. Because whatever x and y are, when you work it down, this number has to equal k. We don't know what k is, but since we know x and y, we can do the algebra necessary and find k. Okay? So if you know what to do after that explanation, pause the video right now and give it a shot. Okay, let's get started. X, y. So plug in step. 9 times 3 for my x minus 2 times 5 for my y equals k. So we still don't know what k is, but we're really close. 9 times 3, 27, minus 2 times 5 is 10, equals k, so 17 equals k. Now you might be asked to write the line equation, so in which case that would just be 9x minus 2y equals our 17. So that's the full equation of this line. Okay, one last one of these slightly more tricky or complicated problems. Still the same exact concept. We're using the same knowledge to answer these questions. Okay, now they're asking us to find a, lowercase a, given that this point, and here's that lowercase a. So we don't know what the x-coordinate is. We do know what the y-coordinate is, and that's minus 2. So find a, given that this point, a, negative 2, lies on this line equation. And notice how this one is solved for y, so this is a gradient intercept form, different form, we can still go with that. We just have to find a. Okay, so all we do is we do a plug-in step. We have x and y, we plug it in here, and what's going to happen is we're going to have one variable in that equation, and that's going to be our a. And then we can solve for a. So watch this. My y is negative 2, so I'm just going to bring this down. Minus 2 equals 6. Now here's my x, it's just a. I don't know what it is, so I'm just going to plug it in right like that. 6a minus 14. Now I just need to solve for a. I have a full-on equation with just one variable. We can solve for that all day long. I'm going to add 14 to both sides. So I'm going to get 12 equals 6a. Now I'm going to divide by 6 on both sides to cancel the 6 away from the a. 12 divided by 6 is 2. So a is 2. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.